The sun, this blazing sphere of fire and light, has for centuries stood as a symbol of stability, power, and life in the human imagination. Yet within the heart of this colossal star, a phenomenon unfolds that reshapes our perception: rain. Not rain made of water, but rain made of plasma, fiery particles that cool within the solar corona, condense, and fall back toward the sun's surface like incandescent droplets. This astonishing phenomenon, known as coronal rain, has long captivated scientists. How can cooling occur in the hottest layer of the sun's atmosphere? Why does this rain sometimes form with incredible speed? And what secrets lie within the elemental makeup of the solar corona that drive such complex behavior? In this article, we take a scientific and analytical look at a recent breakthrough in solar physics, one that not only reveals the beauty of cosmic processes but also unlocks deeper understanding of the sun's dynamics and its influence on Earth. Yes, it rains on the sun. Scientists have recently uncovered the mystery behind the rapid formation of this extraordinary phenomenon in the solar corona. Of course, this isn't rain as we know it. Rather, during solar rain, cooler and denser plasma masses accumulate in the corona, the outermost layer of the sun's atmosphere, and then cascade downward toward the surface. For years, researchers struggled to understand how coronal rain could form so quickly during solar flares. Now, scientists at the University of Hawaii have finally solved the puzzle: fast-moving flows of elements like iron, silicon, and magnesium. Radiation from the corona causes plasma in this layer to cool. However, the elemental composition of the corona is not uniform. It varies over time and across different regions. Most existing models ignore this variability, assuming a constant elemental distribution throughout. As a result, these models fail to accurately explain rapid phenomena like coronal rain, which occur during flares and in active regions. Since the amount of energy lost through radiation depends on the type and abundance of elements present, oversimplifying their behavior obscures the key physics behind the sun's atmospheric processes. The research team discovered that changes in elemental composition known as elemental abundance can directly explain why coronal rain forms so quickly. To model the cooling of plasma more precisely, they updated a simulation tool called Hydrad. Unlike older models that assumed a static elemental mix, the new version allowed for changes in composition across space and time, especially for low first ionization potential, low FIP, elements, which play a crucial role in solar activity. The scientists even added a new equation to the model to track the movement and variation of low FIP elements. Comparing the results of the updated model with the older one revealed a much closer match to actual observations of coronal rain. In the new simulations, which accounted for changes in elemental distribution across the corona, researchers found that coronal rain began to condense after just 35 minutes, whereas previous models required hours or even days of heating to explain the same phenomenon. The research team concluded, elemental changes are essential to understanding plasma cooling in the solar atmosphere, and as we've shown, they can directly trigger coronal rain. Jeffrey Reep, an astronomer and co-author of the study, added, "This discovery is highly significant because it helps us understand how the sun truly works. The identification of elemental composition as a key factor in the rapid formation of coronal rain marks a turning point in our understanding of the sun's complex behavior." This finding not only challenges previous models but also opens new avenues for more accurate predictions of solar phenomena and their effects on Earth. By updating simulation tools and incorporating elemental variability, scientists can now model plasma behavior in the solar corona with greater precision, a vital step toward deeper insight into the star that sustains life on our planet. This research shows that even within the brightest celestial bodies, the smallest changes can give rise to astonishing and impactful phenomena. A more refined understanding of coronal rain not only enhances our grasp of solar dynamics but also has practical applications in the field of space weather, an area that studies the impact of solar activity on Earth, satellites, communications, and even astronaut health. From a philosophical perspective, this discovery reminds us that even the sun, a symbol of power and constancy, experiences moments of collapse and renewal. Coronal rain, while a scientific event, can also be seen as a metaphor for the inner cycles of existence, from the release of energy to the return to origin. Just as plasma cools and falls within the solar corona, perhaps in life too, moments of descent are preludes to rebirth. Ultimately, this research not only helps us understand how the sun operates, but also reminds us that science, alongside beauty, can serve as a bridge between logical understanding and cosmic reflection. Each droplet of solar rain carries a story of balance, transformation, and truth still hidden within the stars.